Hey, today we're going to talk about covalent bond character. We've got Science Cat here with a fun joke for us. Okay, so when we're talking about bond character, we're talking about the ionic or covalent nature of a bond. So this is what type of bond we're looking at. Is our bond ionic? Is it covalent or is it metallic? And today we're really going to focus in on covalent, but let's talk really quick about how we can identify bond character. So generally, when we want to identify the characteristics of a bond, we are looking for the difference in electronegativities of the two atoms in the bond. If the difference between those electronegativities is between 2 and 4, then we're looking at an ionic bond. That means that the electron has been completely transferred. So it's moved from one atom to the other atom. If the difference is less than 2, so if it's between 0 and 2, then we're looking at a covalent bond. That means that those atoms actually share kind of custody of that electron. So our bond character really just tells us if electrons are being transferred, and that would be ionic, or if they're being shared, and that would be covalent. One way that we can figure out the difference is by looking at a periodic table which has relative electronegativity values. So you'll find that resource in our assignment for the day. Okay, so next up, we want to define polarity. So when we look at the dictionary, it says that polarity is a property of having poles or being polar. So a lot of times when I think about polarity, I think about the north and the south poles. So there are kind of these polar opposites. In chemistry, when we talk about polarity, we're talking about a molecule having distinct regions of very different charge. So one region might be more positive than another region, which would then be more negative. And this polarity occurs when electrons are shared unequally. So we would have one region with kind of more electrons in it, and that would be more negative. And then the opposing region would have less electrons, so it would be more positive. And when we have this polarity, this results in our molecule being asymmetrical. So it does not have symmetry. It's not the same on each side. We therefore have poles, so two distinct regions of charge. So that takes us to covalent bonds. So just a reminder from what we've talked about before, covalent bonds form when non-metal atoms share electrons to satisfy their octet and become stable. So remember, when we're talking about non-metal atoms, we're talking about those atoms on kind of the top right-hand side of our periodic table, as well as hydrogen. And when we talk about satisfying the octet, we know that all atoms have an outer valence shell that can hold up to 8 electrons. And when we reach that 8 electron point, we have a stable configuration. And that means that our atoms will be not as reactive as they normally would be. So the whole point in bonding is that atoms become more stable by satisfying this outer valence shell and having 8 valence electrons. When we talk about the characteristics of covalent bonds, they are generally insoluble in water. That means if we mix them with water, they wouldn't mix well. They don't conduct electricity. So if we did mix them with water and they did dissolve, like sugar does, it wouldn't conduct electricity. They can be a solid, liquid, or gas in phase. So if we see something in any of those phases, they could be covalent compared to an ionic compound, which is generally just solid. And then the big thing is if we are looking at a chemical formula and it's only non-metals in the chemical formula, then we know that that's a covalent bond. All right, so that brings us to our two polarity or our two types of covalent bonds. The first one is nonpolar. So when we say nonpolar, really what we're talking about is there are no poles or that asymmetry in our molecule. So nonpolar covalent bonds form when electrons are shared equally between the two atoms in bonding. So this generally occurs when the difference in electronegativity of the two atoms is between 0 and zero point 0.4. So some examples of this are diatomic atoms like hydrogen gas, which is H2, or chlorine gas, Cl2. So we have some examples here. If we had two polar bears sharing an ice cream cone, They're relatively the same strength, so they're going to have a hard time stealing the ice cream cone away from one of them. Same with our penguins. We have two penguins sharing an ice cream cone. They're relatively the same strength. They're going to have a hard time, one of them eating more than the other. All right, now it comes down to polar covalent bonds. So polar covalent bonds occur when there are electrons that are shared unequally between the two atoms in the bond. And this happens because the electronegativity of the two atoms, the difference between them is between zero point 0.4 and 2. So there's this larger kind of strength. So remember, electronegativity is the ability of an atom to steal electrons in a bond. So what happens is the more electronegative atom attracts those electrons greater, and that means that it's able to pull and hold those electrons closer to itself, and this creates this kind of semi-negative charge on that particular atom. When that happens, that other atom in the bond has just gotten those electrons pulled away from it. So now it's more positive, right? Because electrons are negative. So if those electrons are moving further away from that one atom, that atom becomes positive, and the one that they're moving closer to becomes more negative. So an example of this is hydrochloric acid, and we'll see this is kind of demonstrated by our polar bear and our penguin again. That penguin's the relative strength ability to hold on to that ice cream cone or electron, really, if you think about it, um, is a lot less compared to the polar bear. So the polar bear ends up spending more time with those electrons. It would be more negatively charged. In this case, the penguin doesn't get as much time with those electrons, more positively charged. Another example of this is the water molecule. We have water shares electrons between hydrogen and oxygen. Oxygen is more electronegative than hydrogen, and so it's going to have that electron, hold that electron closer to the oxygen than the hydrogen, and that means that that oxygen has that semi-negative charge, whereas that hydrogen is going to be more positive. So let's summarize this really quick. We've got nonpolar covalent bonds form when the bonding electrons are shared equally. So this means that there's very little electronegativity difference between the two atoms. Polar covalent bonds occur when the electronegativity difference between the two atoms is a little bit bigger, and those electrons then are shared unequally. So in this case, we see it as in terms of a tug of war. All right, there we go for our bond character of covalent bonds.